Hi everyone. So today we're looking at question 13, which is the last question in story sheet 4. So the question says, sketch the graph of each of the following rational functions, indicating the intercepts, the vertical asymptote, the horizontal asymptote, and the slant asymptote if they exist. And it's also telling us to indicate the domain and the range in each case. So let me just explain something on the asymptotes. So an asymptote is simply just a line which can be drawn either vertical or horizontal, which no matter how long you draw the curve, it will never meet its asymptote. So the asymptote and the curve will never meet, but the curve, as the line continues going, it keeps on moving towards the asymptote, but they will never meet. That's the asymptote. So to find the asymptotes, maybe there was the vertical asymptote. So to find the vertical asymptote, if you've been given maybe the function f of x being equal to ax, so this is a here, you have ax to the power m over bx to the power n. So the vertical asymptote is found by just equating the denominator of that rational function to 0. So when you equate bx to the power n to 0, the values of x that you are going to find are the ones that are called the vertical asymptotes. And then to find the horizontal asymptotes, there now you need to check the powers. You need to check the value of m and n. So if m is less than n, then the horizontal asymptote is just y is equal to 0. But if m is greater than n, yeah, you just excuse me, I have a flu. Yeah, okay. So if m is greater than n, if m is greater than n, then the given rational function has no horizontal asymptote. No horizontal asymptote. So it has no horizontal asymptote. Then when m is equal to n, the asymptote there is just the coefficients of so the asymptote there will just be equal to a over b. A over b will be your asymptotes. So let's quickly move on to finding the slant asymptote. How do you find the slant asymptote? So given this given this rational function, to find the slant asymptote, so the slant asymptote only exists when the power of the numerator is greater than the power of the denominator. In other words, when m is greater than n, that's when you can have the slant asymptote. And then how do you do that? So you're going to divide the denominator into the numerator, and then the quotient that you're going to find is the one that is called the slant asymptote. So you divide this bx to the power n into x to the power m. So when you divide the two, you are going to find your answer, which is cx. You are going to find this answer, which is cx to the power, maybe I would say to the power r, because we don't know the power that you are going to have there. So when 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 you have such now, how do you find the slant asymptote? So the slant asymptote is simply just this part there, which is the quotient. So the slant asymptote, you just get that part there, which is cx to the power r. That is the slant asymptote. When it comes to sketching, since it's slant, these are the curves that you see. Maybe they are somehow like this, and then you have maybe something like that and something like that. Okay, so let's quickly move on to serious business now. We begin to sketch what we've been given there. Okay, so the first question says -1 over x plus 1. So how do you sketch that? So before you know how to sketch this, you need to understand that if you've been given to sketch something like this, fx is equal to 1 over x, your graph will simply just come out like this. And then if there is a negative there, it means that your graph is going to be in the other two quadrants. And then if you have, maybe for instance, the same 1 over x, and then it has been displaced by 1, it means that your graph is going to come out like that. So it has been displaced by 1, and then it will go up like that. And then if, for instance, maybe it's like this, it means that it will also be displaced, but to the right, I mean to the left. So if you have a negative there, then it's going to go to the right. So it will be displaced in this manner. And then according to these questions which I've given as examples, the asymptotes there, we have x is equal to 1 and y is equal to 0. How did I find this one? I just equated the denominator to 0. So let's quickly begin to sketch. So let's find the vertical asymptote. The vertical asymptote is just equal to, you get the denominator there, you equate it to 0. So you say x plus 1 is equal to 0. And then your value of x is just going to be equal to -1. So this is your vertical asymptote. And then how do you find the horizontal asymptote? So the horizontal asymptote is just simply, since we know to say the power on top there is less the power down there by 1, hence the horizontal asymptote there would just be equal to y is equal to 0. That's what I explained. Let's quickly move on to finding the slant asymptote. So whenever you find an equation with a horizontal asymptote, in most cases it normally has no a slant asymptote. So meaning when we talk about the slant asymptote, we don't have. Why? Because the denominator, I mean the numerator there is less than the denominator, so we have no slant asymptote. No slant asymptote. Then what follows next is now finding the x and the y intercepts. So to find the x-intercepts, we know to say in the x-axis, the value of y is equal to 0. So we find the x-intercept. The x-intercept there is going to be equal to, so the x-intercept, in the x-axis, the value of y is equal to 0. So I'm just going to put a 0 there. And then we cross multiply there. So we're going to have 0 is equal to -1 as our answer, which is simply telling us that when we say 0 is equal to -1 over x plus 1, if we try to make x the subject of the formula there, it's not going to be possible, because we're going to have 0 is equal to -1 as our answer. Hence, this curve has no x-intercept, meaning it does not cross the x-axis. Let us now find the y-intercept. So in the y-axis, we know to say the value of x is equal to 0. So the y-intercept, we know to say the y-axis, the value of x is equal to 0. So we put 0 where there is x there, meaning we're just going to have our final answer as -1 over +1. So which is simply just going to give us -1. So it's cutting the y-axis at -1. So let's now quickly move on to sketching. So we have 0 there. How do we sketch now? So we first start by writing the asymptotes. So we draw the the vertical asymptote, which is at -1. So that is the vertical asymptote. Let us also draw the horizontal asymptote is y is equal to 0, which is just this same line. So now from there we can now move on to what is called finding the points, the approximate points that we can use to sketch our curve. So how do you find that? We use the table of values. Let us find, we have x and y. You can either say y or f of x, still the same. So on the x-axis, let's try to put 0 where there is x. When we put 0 there, we're going to have -1 as the answer. Let's try to put 1. When you put 1 there, 1 plus 1 is going to be 2. -1 over 2 is going to be the answer. Let's try to put -2 there. Put -2. -2 plus 1 is going to be -1, meaning we're going to have 1 there. Let's try to put -3 there. So we put -3. -3 plus 1 will get 2. -2, and then -1 divided by -2, we're getting 1 over 2. So let's try to plot these 4 points. We have 0, -1, 0, -1. Is it okay? So we have 0. Is it 0, -1? The value of x is 0. So we have this point somewhere there. 0, -1. Yes. This point. And then we have 1, -half. 1, -half. So a half of -1 there. So meaning it's going to just come out like that. And then it's going to cut the y-axis at -1, because -1 was our horizontal asymptote. So this is how it's going to come out. This is, -1 was the y-intercept, which is here. Then our horizontal asymptote is y is equal to 0, which is this one here. And then let's also plot these other 2 points, -2, 1. So -2, if this is my 1 there, it's going to be there. Then we have -3, half. -3, half of 1 there, so it's going to be there. So meaning the curve is just going to be like that, to pass through that point and then that point, to go like that. So basically this is how your curve is supposed to come out like. So now how do you find the domain and the range? So the domain will just simply be you find you equate the denominator to 0 to find the domain. So the domain there is just going to, when you equate this to 0, you're going to have x is equal to -1. So what happens when you put -1 there where there's x? When you put -1 there, you're going to have undefined as your answer. So which implies that -1 is supposed to be part of the domain. So the domain will just be d is equal to, we have all real numbers excluding, so we have all real numbers excluding -1. So that is going to be our domain. Let us find our range. So our range is just going to be equal to all real numbers excluding, you can finish up this way, excluding 0. Where have I gotten this 0? You can see where these curves are passing. There's no probability of us having a curve to pass through this point, which is 0. Or if not that, you can just try to find f inverse of x in this function. When you find f inverse of x in this function, and then you find the domain of that inverse function. So the domain of your inverse function is called the range of the main function. Alright, let's quickly move on to the other question. So I'll also do question 2, and I'll do maybe, I'll do question 2, maybe even question 3, and question 4 maybe I'll just do all of them. So let's do another one. So the other one now is saying we find this part, we find x over x squared minus 3x minus x minus 4. So let's okay. So let's do what's this. Let's begin. We first find the vertical asymptote. So we said for the vertical asymptote, you equate the denominator to 0. So when you equate the denominator, which is x squared minus 3x minus 4 to 0, when you equate this to 0, you are going to have your values of x being equal to, the first value of x there will just be equal to -1, and then the other value of x will be equal to +4. Let's also find the horizontal asymptote. So to find the horizontal asymptote, you simply look at the powers there. So since the power of the numerator is less by 1 of the power of the denominator, then the horizontal asymptote is just simply y is equal to 0. And then since the numerator's power is less than the denominator's power, then this given function has no slant asymptote. So there's no need of us finding the slant asymptote. Let us find the x and the y-intercept. So the x-intercept, you equate in the x-axis, we know to say in the x-axis, the value in the x-axis, we know to say in the x-axis the value of y is equal to 0. So we equate this function to 0, we're going to put 0 there. When you cross multiply, you're going to just have x is equal to 0 as your x-intercept. And then for the y-intercept, we know to say in the y-axis, we know to say in the y-axis, the value of x is equal to 0. So in the y-axis, where there is x, you put a 0, So meaning you just have your answer, meaning your y-intercept, meaning your y-intercept there will just be equal to 0, because when you put 0 while there's x everywhere there, you discover that y will just be equal to 0. What else is remaining? I think we can now go into sketching. So our curve is going to look like this. So you first put your asymptotes. We have x is equal to -1, so I'll put my -1 there, and then x is equal to 4. So these are my two vertical asymptotes. Okay. So from there, we can now begin to do this. We can now begin to sketch. We can now begin to sketch. So how can you sketch? How do you know where your curve is going to be and how it's going to bend? You use what are called what is called the table of values. So you use the table of values. You put x there and y there. So when you put -2 in this expression, you discover that your solution will just be -1/3. You can try it. You also try to put maybe -3. We are going to have -3/14 as your answer. Try to put, so these numbers where I'm getting them, the values of x, I'll first start by getting the numbers that are on the right hand side of the vertical asymptote. I'll get on the middle and I'll get outside this side. So I've gotten two numbers from the right hand side of the vertical asymptote. Now let me get the numbers on this other side of the asymptote, which is the right hand side of 4. So I'll get 5. So when I put 5 there, I'm going to have 5/6 as my answer. So when I also try to test 6, when I test 6 there, I'm going to get 3/7 as my answer. So this 6, try to put it there, you get 3/7 as your answer. And then maybe lastly, let's try to test also half, something that is at least in between these two asymptotes. We try to test half. So when you put half there, you get 2/9. 2/9 as your answer. So let's try to plot these points. When you plot -2, -1/3, so -2, -1/3 is just somewhere, I will approximate it to be maybe there. -3, -3/14, yeah, somewhere maybe -3, -3/14, which is just going to be maybe somewhere there. So it's going to be, it's going to be somewhere there. So meaning my curve will be drawing near to the horizontal asymptote there, and then to pass through that point and then to go like that closer to the vertical asymptote. So this is how my curve is going to come out. And then this side also, when you plot them, you discover that it's going to be like that. And then in between here, when you try to plot the last point there, you discover that you have something that will look like this. And it's cutting the x-axis at x is equal to 0. So meaning you have something that will look like this. Okay, so basically this is how your graph is going to come out. And then apart from that, we find the domain and the range. So the domain and the range is just, the domain is just all real numbers. So D is just equal to all real numbers excluding the vertical asymptotes, meaning excluding -1 and 4. And then the range is just going to be all real numbers. So the range is just going to be all real numbers. Yes. So let's okay, so I think let me quickly go on to the next question. So okay, I will just be doing them very quickly, then you do them on your spare time, bit by bit, where you need to understand everything, because otherwise you do them in the same way that you have done. So I'm just going to be helping you finding the vertical asymptotes, the horizontal asymptote, and even sketching it in a quicker way. So this one here, to find the vertical asymptote, you equate the denominator to 0. When you equate the denominator to 0, you find your values of x to be x is equal to, I think that would be -4 and 1. So that would be x is equal to -1 and x is equal to, x is equal to +1 and x is equal to -4. And then to find the horizontal asymptote, and you are going to have, since the denominator's power and the numerator's power are equal, meaning the horizontal asymptote will just be equal to 3 over 1. You get the coefficients of the leading terms. So meaning the horizontal asymptote is just going to be y is equal to 3. And then what else? We try to find the x-intercepts. So we know to say in the x-axis the value of y is equal to 0. So we equate this to 0. When you cross multiply them, you are going to discover that your value of you're going to discover that your values of x, so the x-intercept, to find the x-intercept, you are going to have your values of x being equal to 2 and x is equal to -2. So at these 2 points, that's where the curves are cutting the y-axis. Okay. So that's where the curves are cutting the x-axis, and then you have your y-intercepts there, the y-intercept. So on the y-intercept, we know to say the value here, our value of y was equal to 0. Now in the y-intercepts, the value of x is equal to 0. So meaning while there is x there, you put 0, meaning you're just going to have your value of y being equal to 3, because when you divide this -12 by 4, you get 3. So this is going to be your y-intercept. And then we quickly move on to sketching. So your sketch is going to come out like this. Your curve is going to come out like that. You have your horizontal asymptote there, which is at 3. You have your horizontal asymptote, which is at 3. And then you are going to also have your 2 vertical asymptotes, which is +1 and -4, like that. Yes, so this is what you are going to have. And then from there, we know to say our curves are cutting the x-axis at -2 and 2. So meaning when you sketch, when you use the tables of values, you're going to have something like this. So here where it's cutting the x-axis, this is the point which is called 2, and then we also have something like this. Something like that. It's cutting the y-axis at 3, and then it goes down like that. So this point is -2, which is this one there. And then we also have this part, this side. When you use the table of values, you see that it's going to come out like that. Yes. So let's try now to sketch the last question there. So the last question there, I think it's the only question that has the slant asymptote. Why do I say so? Because the numerator's power there is less than the denominator's power. So what you do is you find first the vertical asymptote. So the vertical asymptote is found by equating the denominator to 0. So that is our vertical asymptote. And then we also find the horizontal asymptote. So the horizontal asymptote is just found by looking at the powers. So if the power of the numerator is greater than the power of the denominator, meaning we do not have the horizontal asymptote, we don't have the horizontal asymptote. Hence we try to test for the slant asymptote. So the slant asymptote is present because we have the denominator there. We have the denominator there being less than the numerator. So how do you find the slant asymptote? By using the long division to divide. You can either use long division or synthetic. You divide and then find the quotient. So we try to find the quotient now. So we use long division. You have x there, then inside there you have 2x squared, then you have plus 0x, then you have plus 1. So we begin to divide this x into that, into 2x, you're going to have 2x. 2x into 2x squared, you're going to have 2x. When you multiply there, you have 2x squared. Then when you subtract, you have 0 there. So you bring down this 0, x into 0, you still have 0. So you're going to have 0 there. So when you multiply there, you have zeros again. When you subtract, you still have 0. Then when you bring down this one, x into 1, x into 1 there is 1 over x. When you multiply there, you have 1. Okay, so when you subtract, it's going to be like that. So having found that, we said the quotient is always the slant asymptote. Oh, sorry. So this is, I think it's supposed to be, okay. Let's also try to use synthetic division, because I think maybe this one has to be a remainder and not what we have done. But okay, let's try to use synthetic division there. So we have x, I think we have no option but to just use long division, because I thought maybe synthetic can work. Now it can't, because we only have x there, we don't have a number, we don't have a 0, we don't have any 0 there yet, so we only have x. So meaning here we are just supposed to end there. Okay, let me do this. So this is basically what we were just supposed to have. We're supposed to have something like that. sorry, this is supposed to be x, yeah. Alright, so this is what we're going to have. So the horizontal asymptote that we have is just this one here, 2x. So 2x is basically the horizontal asymptote that we have. So the horizontal, the slant asymptote that we have. So the slant asymptote here is y being equal to 2x. So the slant asymptote here is just y is equal to 2x. So when it comes to sketching now, you have something like this, and then you're going to draw your slant asymptote there, which is 2x with a gradient positive 2. And then, so this is y is equal to 2x. And then you also draw your horizontal asymptote, which is x is equal to 0, which is just the same line here. This is x is equal to 0. And then this is our 0, which is in the x-axis. And then when you use the table of values there, you use the table of values, you can draw there, you sketch, you have your x this side and your y that side. You can try to test numbers. When you put 1 there, you get 3. When you put 2 there, you get some number here, I think it's 9/2. Yes, when you put that, then from there, when you plot points, you pick about 4 points on the left and on the right hand side of the vertical asymptote. Then once you pick those 2 points, try to test them, you discover that you have something like that. So this is going to be your solution. This is going to be your solution. So to find the domain and the range. So the domain is just given by all real values excluding 0. So the domain, you just equate the denominator to 0. So the domain will just be all real numbers. You can put any real number there, but not 0, excluding 0. So you finish this with excluding 0. And then what is the range? So the range is just going to be equal to all real numbers excluding it's just all real numbers actually. There's no number that we can exclude from the range there in order to have this function undefined. So the range is basically just all real numbers. So thank you very much for watching. See you in the next question, which is question 1 from tutorial sheet 5.